right, let's see what we got here. So I had to stop here because class was about to start. And here's the similar function I'm working with. It says write a function in factored form representing the volume of the prism. So the volume as a function of x is really simple. Volume, by the way, is length times width times height. And you just write your factors down. That's it. The order might change, but that's it. Now it talks about what the domain of x is. And here's the gist on this. It makes no sense for the volume to be 0 or have an x or negative. That might not even be possible on this question, but it might be. So why did I mention 0 or negative? All right, because it makes sense to talk about that. So one of the things I do is I kind of look at my factors. It makes sense that x has to be more than 0, because if you put a 0 there, the entire volume is 0, okay? The other thing that makes sense is it doesn't make sense for these particular factors to create negative values, all right? So the 40 minus 2x factor has to be bigger than 0, because it has to be positive, and it doesn't make sense for it to be 0. And the 25 minus 2x is bigger than 0. These are kind of concepts of what we call natural domain. It just doesn't make sense for x values to exceed certain things. So if I solve this one, I would have negative 2x is greater than negative 40, which means that x is less than 20 because I divide out the negativity. And think about that. It would make sense for x to be less than 20, because if you put a 20 in here, that makes this 0. If you put a 21 in here, that makes this negative. That's why I'm talking about kind of natural domain concepts. Same thing with this guy. We move the 25 over and we divide by the negative 2 and we get 12.5 as a decimal. All right. So this guy's already been kicked out the window. Well, actually has he? This guy would be the left domain, and this guy gets to be the right domain. Because if you've got to be less than 12.5, this isn't needed. So the domain is that x is stuck between 0 and 12.5. It's got to be bigger than 0, but less than 12.5. Part 3 is a straight up calculator problem. You're going to place your equation in y equals, and you're going to use the maximum function. That's what you got to do. So the function I wrote was 40 minus 2x times 25 minus 2x times x. And I'm just going to zoom 6 it, and I'm going to play with my window. I got a hunch this thing has a volumes up in the thousands of centimeters. Like, I did a zoom 6 and I saw nothing, but I can see this blue line going straight up. So just for the crap of it, I'm going to set a y max of 3,000. I hope it's 3,000, otherwise I got to change the problem. Okay, so yeah, something I got to change on this little similar thing. There's a maximum. Second trace 5, get close. And by the way, that was second trace 4. I said 5. Second trace 4 for maximum. I get left of the maximum, I press enter. Focus that for you. I get right of the maximum, and I press enter, and then I press enter for the guess. And it turns out that the maximum value is actually 5. That's amazing. This came out to be 5. I know it says 5.000016. That's rounding crap. It's actually 5. Because look at the y value. It's perfect. So an x value of 5 centimeters makes this true. All right. For the purpose of the similar question, I can't use 3,000 because the maximum volume of this prism is 2,250. And by the way, I did mention something, and I'm going to talk about it. I was talking just a few seconds ago about natural domain. You can also look at graphs, and you can count, right? Right here is where this graph starts entering negative territory, and that's happening if you count. If you play along in your own calculator, That's happening when x is between 12 and 13. It's happening right there at 12.5. All right, so for the similarity purpose, I'm going to change this to a 2000, and I want to know what x value makes this true. So I'm going to take my equation, which is already in y1, and I'm going to set it equal to 2000, and I'm not going to do any of this by hand. This is in y1, this is in y2. I'm going to use the intersect feature. So y equals putting a 2000 in y2. Not going to play with my window because I know it's already right. And I'm going to hit second trace 5 for intersect, and I'm going to get close on the left, and I'm going to press enter 1, 2, 3 times. I know that's hard for you guys to read, but I got an x value of about 3.2004. That's one of them. There's a second answer. All right. Or second trace 5, get that little blinky dude close, enter, enter, enter. I got an x value of roughly 7.0086. So you don't have to know algebra to do that problem. You don't. You just have to know how to set things up, which is an issue. Solve this dude. X minus 7 is equal to the root of 2x minus 6. And I put root notation here. Hopefully that makes it a little easier for you. But your first step here would be to square both sides. Because a square counteracts a square root. To square x minus 7, if you don't know it by now, you better. You write it twice. And if you square the right, the power cancels out the understood root. Ta-da! All right, so what have I got here? I would FOIL, or double distributive property, and that would give me x squared minus 14x plus 49. You had best learn how to FOIL, and you're still equal to 2x minus 6. Keep on going. Get everything on one side. This is a quadratic. You set equal to 0. X squared minus 16x plus 55 is 0. That's what I did there. I set equal to 0. And the reason I set it equal to 0 is because I'm hoping I created something that factors, and this was designed to factor. The one on your test is designed to factor. This one that you're given on your twin is designed to factor. And this does factor. It's x minus 5 and x minus 11 being 0. At least I believe it is. One of these was supposed to be extraneous. Did I do everything right? Looks like I did everything right. But anyways, I get two answers, that x is 5 or x equals 11. So I'm going to see if these things work. All right, so what I'm doing is I'm going to plug the 5 in on both sides, and you can use a calculator to do this. 5 minus 2 ought to equal the square root of 3 5s plus a 4. All right, so 5 minus 2 is 3, and this generates a radical which has a 19 in it. Oh, I looked at the wrong problem. Oops. I was looking up here. I was supposed to look right here. 5 minus 7 is supposed to equal the root of 2 times a 5 minus a 6. Here's the problem. This is negative 2, and that's going to be root 4. The square root of x function is only supposed to return positive numbers. That's something a lot of kids aren't going to remember. But anyways, this negative 2 is extraneous. And if I plug in the 11, I'd have 11 minus 7 equal to the root of twice an 11 minus a 6. 11 minus 7 is 4. And I'd have 22 minus 6, which is root 16. So 4 is 4. We get the check. The real number is 11. So, how can I help you with this? How can I help that make sense? Well, your calculator will always show you the real number. It will always show you the real answer. The calculator always shows the real answer. So let me put x minus 7 in y1 and the root of 2x minus 6 into y2. And I want to repeat that. The calculator only shows you real things. It does not show you things that don't make sense. I'm going to do a zoom 6. There's the x minus 7 line. Here's that. And I'm just going to go out a little farther to 20. And you can see your intersection here. Second trace 5, get close, press enter. 1, 2, 3 times. And there's your intersection at 11. Your extraneous answer would have been the negative square root, which would have done something like that, which, by the way, was not drawn because it's not supposed to be drawn. I hope you get that. There you go. That is number 15, which I expect to be kind of rough. And that's all the time I got. Bummer. Looks like I got 14 and 15 done. I was hoping for more. Looks like somebody is going to stay after school a little bit today, and that somebody is this guy.